So in this class, I will explain how to compute the efficiency of a butt joint. So in the earlier lectures, I have explained about lap joint. Here in this, we will take up a double cover butt joint. He has given the details. So there are two plates here of size 150 mm by 10 mm. 150 mm is the width of the plate and 10 mm is the thickness of the plate. So these two plates are connected by double cover butt joint. So there are two cover plates here on either side. So and also you have the boards arranged like this. You can see that on this member you have two rows of boards. On this member, so these two are the member. This is member 1, this is member 2. On this member also you have two rows of boards. So now here the pitch is given as 90 mm, and of course the head distance are 30 and 30 mm. And in this direction, the center to center distance of the boards are given like this, and the end distance is 30 mm. This is 50 mm. So this is the diagram given. Thickness of the cover plate is 8 mm thick. So this is a double cover butt joint because there are two rows of boards on each member. Now, in the case of butt joint, you will be having two shear planes. So in the case of lap joint, you have only one shear plane. Here you have two shear planes. The first shear plane will be this one. Second shear plane is this one. So there will be two shear planes here. So since there are two shear planes, the boards are subjected to double shear. So whenever you are computing the strength of bolt or bolt value, you have to consider double shear as well as bearing. Now let me calculate the first step is to find the strength of bolt. So strength of bolt, here the diameter of the bolt he has given M16 bolts. So 16 mm black bolts are used here, and your diameter of bolt becomes 16 plus 2, 18 mm, including the clearance. Now we have to calculate the strength of the bolt using two criteria. The first criteria is double shear criteria, because there are two shear planes. In the case of butt joint, you have to calculate the strength of bolt in double shear. The formula, of course, is given in the code book. So as you know, in page number 75 of the code, he has given the formula to find the VDSB is equal to VNSB by gamma MB. So where VNSB, of course, is given by, or you can write directly, I will write VDSB is equal to VNSB is given by so FU by root 3. So you write down the formula. FU by root 3 into 2 times AN into NN, because it is subjected to double shear. So here this value of AN, you can take it as FU is of course 400 MPa for the bolt for grade 4.6 volts. If it is not given, you can assume grade 4.6. 400 Newton per mm square by root 3 into 2 times. So AN is 0.878 times pi d square by 4, which is 0.60 square by 4. So in the NN, of course, is 1. So now here our NN itself is you can take it as 2. So therefore this is the answer. Now here this 400 by if you simplify this one, this gives the value of VNPB divided by gamma MB will be there. So gamma MB is 1.2. Yes. Now if you simplify this, you are going to get the strength of bolt in double shear. So let us calculate this. 2 into 0.78 into pi into 256 divided by 4 divided by 1.25 into 400 divided by root 3. So you are getting 57,948.7. So actually this will be in newtons. So you can convert that into kilonewton. 57.95. Okay, 57.95 kilonewton is the strength of bolt in double shear. Now the second criteria is bearing, strength of bolt in bearing. So for that we have to use the same formula given in page 75 of the code. So VDPB is equal to VNPB divided by gamma in volt. Here this VNPB is given by 2.5 times kV dt into Fu. So this is the formula for the variations. Here Fu is the strength of the plate. So unless it is given, you can assume 400 MPa Newton per meter square as Fu value, whereas here is FUB. So please note the difference. So Kb is the least of there are 4 criteria as you know. So you have the 4 criteria like this. You have E by, so once again in page 75 it is available. So you can just refer that in the code. So it is the least of E by 3D naught. E by 3D naught, one criteria. Second one is P by 3D naught minus 0.25. Third one is FUB by FU. Fourth one is. So all these I have done in earlier videos also, how to calculate the strength of the bolt. So now this, if you simplify, E here is, you can take E as 30 ml divided by 3 times D naught is 18. This is one criteria. Second one is P, which is 50 by 3 into 18 minus 0.25. Third one is FUB 400 by 410, and the fourth criteria is 1. So if you simplify these things, so 30 divided by 54. So 30 by 54 is the first value, which is 0.55 or 0.56 you can take. Second value is 50 divided by 54 minus 0.25, which is 0.67 or 0.68, you can take. Then 400 divided by 410, which is 0.976, and last is 1. So the least among these is this value. Therefore, you can take Kb as this value. Therefore, VNPB is equal to 2.5 into Kb is 0.56 into D is 16 mm into T is the thickness of the thinner plate. Thickness of the thinner plate, of course, you have to take it as this T value, the thickness of the plate. Here in this case, it is 10 mm. Of course, both the plates are of same thickness, both the members are of same thickness, 10 mm, 10 mm. So into this FU value, of course, for the plate is 410. So this also will be in newtons. Let us calculate this. 2.5 into 0.56 into 16 into 10 into 410. So 91,840 Newton or 91.84 kilonewton. We are going to take. Of course, this should be divided by 1.25 to get VDPB. So VDPB is VNPB divided by 1.25 factor of safety. So you are going to get the value as 73.47. Now you can observe that this value is lesser. So among these three values, bearing and double shear, therefore strength of board is the least of these two. So which is VD, SB. You can take it as 57.95. Now since he has asked the efficiency of the joint here, so according to the definition of efficiency of the joint is given by the strength of the joint divided by gross strength of the plate. Please note that efficiency of joint, any joint, lamp forward joint is given by strength of joint divided by gross strength of member or plate. Here member is a plate. Of course, into 100. So we use in percentage. Now, the thing is here, now we have to calculate the strength of joint. This is very important. So the strength of joint once again is computed using three criteria. The first criteria, so now what I will do here is, I will calculate the strength of joint now. So this I will call it as equation 1. Let me substitute here. So strength of joint is calculated using three criteria. The first criteria is based on the bolt value. So here, when we are calculating based on the bolt value, we have to consider the number of bolts which is there in this distance. So you have half plus half, 1. So 1 into 4. So there are 4 bolts in this region. So in the spacing of 90 mm. So what I can write here is strength of joint is equal to, from the first criteria, there are 4 bolts in that region. So 4 into, for 1 bolt the value is 57.95. So 4 into 57.95, this is the first value. So what you will get here, 4 into 57.95, which is 231.8 kilonewton. This is the first criteria. The second criteria is we have to calculate the design strength of plate from yielding consideration. So design strength of plate from yielding consideration. Once again, this is available. The formula is available in page. So page number. So that is tension number for page is there. Page number 32. So page 32. This formula is available. TDG formula. Okay. So this is the formula we have to use. TDG. AG Fy by gamma m. AG into Fy by gamma m. This is second value. AG is the gross area of the plate. So please note that area of the plate is given by width 150 multiplied by thickness 10 mm. So width into thickness. So 150 into 10 is the AG value. The Fy is 250 Newton per meter square divided by gamma m is 1.1. So this will be in newtons. If you convert that into kilonewton, so the value you are going to get is, so 1500 multiplied by 250 divided by 1.1, so 340.9 kilonewton. So this is the second value you are going to get. So all these values we are calculating to fix the strength of joint. There are three criteria to fix the strength of joint. The third one is the design strength of plate from rupture consideration. Rupture. So third consideration is design strength of plate due to rupture. So the plate may fail due to yielding or rupture. So design strength of plate from rupture consideration. So when you are taking gross area, so it is yielding. When you are taking rupture consideration, it will be net area we have to take. So the formula for to find this is once again available in that page 32 only in the code. So TDN formula, this is what we have to use for the plate at 0.9 ANFU by gamma M1. 0.9 ANFU by gamma M1. This is the formula. If you use this, so TDN is equal to 0.9 into, now net area we have to take. To take the net area, so in this, out of 150, you have to deduct the 2 volts. So effective width will be gold holes we have to deduct. So area will be, so 150 minus 2 times 80, this is the width, into thickness of course won't change, it is 10 mm. So see here, so gross area is 150 into 10, net area is 150 minus 2 times the two diameters of the holes into thickness. Into F2 is 410 for the plate divided by 1.25. Gamma M1 is 1.25. Now this also will be in newtons. We can convert it to kilonewtons. So this becomes 0.9 into, so this is 150 minus 36, that is 114 into 10, 1140 you are going to get, into 410 divided by 1.25. So this value is 336.5 kilonewton. Now these three are the values we have to consider to get the strength of joint, the numerator of this. So therefore, strength of joint is the least of these two. Strength of joint is the least of above three values. So therefore, it is equal to how much? So one value is 231.8, second value is 340.9, third value is 366.5. So the least of those three is 231.8 kilonewton. So this is the numerator we have to use in this equation 1. So now the denominator we have to compute. So gross section of the plate, member means plate here, gross section of plate, remember. Once again, this is given by, we have to use the formula 0.9 times Ag into F2. So please note the difference here, 0.9 times Ag Fu by gamma. So this is the formula to find the gross section of the plate. So please note that here we are using net area, here you are using gross area. So 0.9 into Ag is now 150 into 10 into 410 divided by 1.25. This is the Newton. So now it is 0.9 into 1500 into 410 divided by 1.25. So the answer here is into 410 divided by 1.25 is 442.8 kilonewton. Now we got both numerator and denominator. If you substitute in this equation 1, you will get the efficiency of joint. So substituting in 1, the efficiency of the given but joint is equal to numerator is 231.8, denominator is 442.8 into 100. It gives the efficiency of the given but joint in percentage. So 231.8 divided by 442.8. So we which is 52.35%. 52.35% is the efficiency of the given butt joint. So please note that this is an analysis type of problem. This is not design problem. Already they have given the details of the joint. They are asking to find the efficiency of the joint. It is given by this formula: strength of joint divided by cross section of the member. The strength of joint is the least of three criteria which I have calculated. For that, I have to calculate the bolt value of the strength of single bolt, then multiply that by the number of bolts which are existing in this 90 mm width. So then you calculate the design strength upgrade from yielding criteria as well as from the rupture criteria, which is available in page number 32. There is a design tensile strength because normally plates are used to carry the tensile loads or transfer the tensile loads. Then cross section of the plate is computed using this formula. Then take the ratio multiplied by 100. You are going to get the efficiency. In lap joint, bolts are subjected to single shear. In butt joint, bolts are subjected to double shear.